Hello again, welcome to the Software Defined Radio with RTL SDR. On Module 4 we are going to see some elements for the final project, and one of them is the FS-key demodulator. Frequency shift keying modulation is widely used for data transmission. This type of modulation has a very high reliability, and it's based on the use of two frequencies, one for each bit. 0 is transmitted with a frequency F0, and the 1 is transmitted with a frequency F1. So there is a frequency shift to transmit each bit. The advantage is that this modulation is easy to demodulate and it has very high reliability, but the bandwidth is larger than the other one we see, amplitude shift keying. This will be the spectrum of a frequency modulated signal. It has two main lobes separated by the frequency deviation. So the bandwidth is a little larger than the 2 times the frequency deviation. We are going to see on this point how to make and how to use the narrowband FM demodulator to demodulate binary data. As we saw before, the SDR demodulator provides I and Q signal as output, and we will use these I and Q signals to demodulate the information. We will use the narrowband FM demodulator, and as in the case of wideband, it is necessary to put a low-pass filtering after the demodulator. Then we'll use the time scope to visualize the demodulated signal before and after the filtering. One of the main advantages of this FM modulation is that it doesn't need a gain control, because it the information is in the frequency, so we can saturate the receiver that there is no change in the information. This is the block diagram of the receivers that we are going to use. We have the RTL in the middle with a configuration for frequency. Here we are using a FS-key remote control at 868.3 MHz. This frequency is also used as the 433 MHz, and high quality remote controls used to employ FM modulation. So after the RTL we put the FM demodulator, and then we'll see how we need the integrator. We always put the spectrum analyzer to monitorize the data and to see the received signal, and then after the demodulator we put the time scope to see the data. This is the way we can see the FS-key signal of a remote control. I'm using a remote control of a car, which is very stable and use FS-key. We can see that there are two clearly distinguished peaks, which give us some information about the frequency deviation. The distance between peaks is 2 times the frequency deviation. Then after the modulator we'll put the integrate and dump or low pass filter. This integrator is using a high integration factor. Here I have 20 samples as integration factor, and you can see clearly the effect on the signal. This is the input signal, this is the data and noise with a lot of peaks, and this is the output signal where the signal we can see clearly the pulse, and this is some noise. FS-key has a high noise at the output, so it's necessary to fit very well the low pass filter. Then always we use the audio monitoring to check the behavior of the system and as another output for information about the signal. As you can see, we need a decimation factor to fit the sampling rate of the SDR to the sampling rate of the loudspeaker. We fit this decimation factor to 2 to get a 48 kilohertz output. So let's see how it works, the receiver with the system. Here we have the complete system with all the parameters, and now we execute and we activate the remote control. On this point we see the spectrum analysis. This is the pre-filter data with a time scope, and this is the post-filter data. I activate the remote control, and you can see how we can receive the signal and how it's transmitting these different types of peaks. We can take some data string and stop the system to see the data more clearly. There I have stopped the system, and now we can go here and see the data clearly. And here are the data where this type of data uses some special codification that we will explain later. But you can see that we can clearly distinguish the data in all the range. If we go to the signal, the pre-filter signal of this point, we can make a zoom, and we can see here there is a lot of noise, and it's very difficult to distinguish the signal. This is one of the effects of the modulator, of the narrowband demodulator. We have fit the frequency deviation to 3 kHz. We can estimate the frequency deviation, and also we can fit this frequency deviation to get the highest output. If we put here, for example, 8 kHz, the output will have lower level. Execute again. So we have to fit the frequency deviation to get the highest output in the data signal. It's starting, and now here you can see the output has lower level, and still we can distinguish the data, but there is a low level signal. So we try to get the highest output. So that's all. Thank you for your attention.